All right, so to warm up today, let's go ahead and this, by the way, is 5.3b. To warm up, we're going to start by just doing the derivative of this function that's been composed. It's very straightforward. We're talking about chain rule. See what you can come up with. Pause the screen, pause the video, see what you can do. So it's a simple chain rule. So we have the derivative of the outside function. We leave the inside function there, times the derivative of the inside function. So it's pretty straightforward. You shouldn't have had any trouble. If you did, then, we need to work on that. Get rid of this. Okay, so today we're going to be talking about derivatives of inverse functions, which includes finding points of an inverse, which was what 5.3a was about, and then the derivative of an inverse function, which is the new part. And what's really cool is how easy it actually is. So if you recall this equation, we talked about this in the last video, how to figure out the value of the inverse, which basically means when this equation is equal to 3. So we're trying to think of when the equation is equal to 3, not at so not there and not there, and we were able to determine that yes, it was when it was -1. That was so exciting. So we were able to figure out that f inverse of 3 is -1. Real exciting stuff. And let's move on. So this is the part that's going to be new today, is how we do derivatives. Now, inverse functions, if we can just find inverses and just take the derivative, that's the easy way. But sometimes there aren't clean inverses. Now, this function has an inverse. It's going to be a cube root of something, but because there's two x's, finding the inverse straightforwardly is going to be painful. So we are going to work out what we need to do. So what we're going to be doing is trying to find the derivative of f inverse of 3. So we want to, since we've already figured this out, can we do this? And this would be fine if we could find the derivative of the inverse function, which of course requires us to find the inverse function. There's no nice way to find this inverse. We can do stuff with graph and look at the picture and let Desmos find the inverse function with the graph if you want. That's no problem. But doing it another way is a little bit more difficult, and even that is not foolproof. We need an algebraic way to do this. And so we can actually take a cool shortcut. Since there's no way to find the derivative of the inverse at a specific number unless we can find the inverse function as far as we know right now. But let's try to figure out what's going on. So if you recall, if g of x is the inverse of f of x, and we compose them together, we get x. That's basically the way to test if you have the right inverse function, is to do a composition of the two and see what pops out. And if it's x, you have that inverse. This is, again, going way back last year to the first unit in Math 3 Accelerated. That's when we talked about that. So, way back. So we're going to go ahead and do that. Let's go ahead and just find the derivatives of this. So this was the warm-up, what we did a moment ago. It's chain ruling, and that's what our answer is. We know the derivative of x is 1. And so that's all we've got. Again, we're looking for, if we remember, g is really f inverse. So g prime of x is f inverse of x prime. Notice we have to kind of be funky about how we write that because of this -1 here. It gets in the way a little bit. But, so let's go ahead and solve for g prime, which is pretty straightforward, just dividing by this. And so, in other words, f inverse prime of x is equal to 1 over f prime of f inverse of x. So, what does that mean? This is a big deal. It's amazing what this actually does for us. So what we know is that g is the inverse function of, if g is the inverse function of x, then the derivative of the inverse function is equal to 1 over f prime of g of x, provided that that's not 0. So as long as the number we're looking for right here doesn't equal to 0, we're all set. So we're going to switch over our notation here. And so we're looking for this. So just plugging in 3 into the places we had before. That's all that's happening here. So what do we know? We know a little bit ago in a slide earlier, we found out that g of 3 was f, since f inverse of 3 is negative 1. We know g of 3 is negative 1. And we know the derivative of f of x is 3x squared minus 4. So what are we doing here? Now we can find g prime. So there's a lot going on here, but we're basically going here to do this. So all we're going to do is take the knowledge we have of these pieces of knowledge and go for it. It's pretty straightforward because we need to find f prime of g of 3. So that's f prime at negative 1. We plug in negative 1. 3, negative 1 squared is positive 1. 3 minus 4 is negative 1. No big deal. Our answer is negative 1. So this is our new definition. If you haven't had a chance to write it down yet, make sure you write it down. Let's go ahead and see what it refers to the point on the graph. How can we determine any? So, notice this relationship. So it's the way we left it this way because it's a reciprocal. The slope of a function, its inverse, are reciprocals. And let's just go back. Let me do that one more time. So there's our point, and we know that we ended up with the reciprocal here. And we left it, you can't actually see that because it's not on the screen. Give me 1 second, I'll be back. Just quickly change the dimensions here a little bit so that this is on the screen. So we've got 1 over negative 1, and we left it this way instead of rewriting it to show the reciprocal relationship. Okay? The slope of a function and its inverse are reciprocals. So if you look at this, here's my original function. This would be like 2 to the x, or probably e to the x. I'm looking at it, it's probably e to the x, and this is natural log of x. And the slopes of these two are reciprocals of one another, which means something amazing as far as shortcuts are concerned. It gives us a different perspective on some of the other things we can do shortcut-wise, so we don't have to go through the same process every time because of what's happening. Remember that an inverse function is just its reflection around the line y equals x, and so everything just switches places. And so what happens with the slopes or the derivatives is that they are reciprocals. So let's see what that means for us. So here's another function, and we want to find the derivative of the inverse at 3. So technically that means we need to figure out what when f of x is equal to 3 so that we can plug it into our new formula, which basically, led us to be f inverse prime of x is equal to 1 over f prime of f inverse of x. Okay, so that's our formula. And so technically at this point we need to do all that work, but we also just discovered a minute ago that they're reciprocals. So all I really need to do is take the derivative of f of x, and that will give me 3/4 x squared plus 1, that's our derivative, and evaluate that derivative at 3. And so that gives me 3/4 of 3 squared plus 1. Not evaluating it at 3. I'm evaluating it at that. I didn't actually figure the answer to this out. A minute, let me think about this. I'll be right back. So what I've done is I took a look at the graph of this and where it intersected that, and discovered that they intersect at x equals 2. So my point is 2, 3. And so I need the slope at that point. So I'm going to actually go ahead and find the slope at 2. So f prime at 2 is equal to 3/4 over 2 squared plus 1, which is equal to 3/4 times 4 plus 1, which is equal to 3 plus 1, which is equal to 4. So that's the derivative. And so f inverse prime of 3 is equal to 1/4 because it's the reciprocal. And so that's that relationship that we discovered. It makes it fairly, you've kind of got a couple of shortcuts here. Mostly the big shortcut is you really don't have to remember this. It's a reciprocal relationship. The tricky part is figuring out what value you're looking for. That's the hard part. So let's see what we can do. So that's that picture back up of, see, it's here at 2. And so that's what I'm looking for is 2 and the slopes, which are reciprocals of one another. So that's just a picture to back up the work we just did. So we want to find it for any real number a. This is a practice problem. Go ahead and see what you can come up with. Pause the video now. I'm going to have the answer on here in just a minute. You're looking, first of all, you need to figure out when f of x is equal to -1. So that's the first step, is figuring that out. -1 equals this. And so you might need some factoring techniques, or you can use a calculator to show when they're equivalent, whatever works. But that's the first thing you're going to try to figure out. Once you know that, see if you can find the derivative of the inverse at that point. So go ahead and pause the video, see what you can come up with. All right, so here's my answer. F prime of -1 is equal to 1/7. And again, so what I've done here is I first figured out where the equation was equal to -1. Some basic factoring by grouping to figure that out. These led to fake numbers. That's the real answer. Then I found the derivative of f of x and evaluated it at 2. And my answer is 7. And so this is 1/7 because they're reciprocals. So that's how you're going to do that. And then we have one more. So go ahead and pause again and see what you can come up with. So what we have here is we have the sine of x is equal to 1/2. That happens at pi6. And so then I took the derivative, which is cosine of x, and then I set that the derivative at pi6, which is radical 3/2, and then I did the reciprocal. So I've got 2 over the square root of 3, which is 2 squared roots of 3/3. And so it's really straightforward. It's a great shortcut. Please use it. Good luck to you, and I will see you soon.